This is a very interesting video about the omega oxidation of fatty acids. We are aware that the major pathway for the oxidation of fatty acid is beta oxidation. At times there are alpha oxidation happening very specifically in peroxisomes or in endoplasmic reticulum or in mitochondria of certain organisms. Omega oxidation is a pathway where the oxidation is beginning at the omega carbon atom. So we know this is an example of a fatty acid, and this pathway will happen for short chain or medium chain fatty acid. We have given example of a 12 carbon fatty acid, and this is lauric acid. Now in this fatty acid, this is the omega carbon atom. The oxidation will begin from the omega carbon atom, therefore this is called omega oxidation. And this will happen very specifically in the endoplasmic reticulum. It begins in the endoplasmic reticulum. Let us see how this proceeds towards oxidation. In the first step, step number 1 is in the conversion of this methyl group, the omega carbon atom, into an alcoholic group. And this alcoholic group conversion is carried out by a P450 system. This P450 system is a mixed function oxidase. We know from our previous sessions that requires a molecule of oxygen, and it is an NADPH dependent enzyme which will convert the omega carbon atom into an alcoholic group. We call the first end product as fatty omega hydroxy acid, and in the second step, this fatty omega hydroxy acid is undergoing a reduction reaction, that is by alcohol dehydrogenase, and the alcoholic group is now getting converted to an aldehyde group, and that is catalyzed by fatty omega alcohol dehydrogenase enzyme. So now once you have this aldo group, the next step is another aldehyde dehydrogenase will act on it, which is an NAD plus dependent enzyme that is converting the aldehyde group into an acidic group. So now you can see that at both the ends, at the alpha end as well as at the omega end, the fatty acid has been converted to an acidic group. So therefore this is a dicarboxylic acid. What happens to the dicarboxylic acid? How it will undergo beta oxidation? Now we should also understand that both the ends are one and the same, and beta oxidation can begin by activating this fatty acid at either end. Either it can activate at the alpha group, or the omega group can be activated by fatty acyl-CoA synthetase enzyme. Let us look at how the beta oxidation will happen to this dicarboxylic acid. Let us look at how beta oxidation happens to this dicarboxylic acid. So therefore, fatty acyl-CoA synthetase is the enzyme. This is the enzyme that will activate fatty acid. ATP is required, AMP plus PPI, and a coenzyme A is needed. So the coenzyme A can get attached here as well as here. Wherever it attaches, the reaction will be the same. So let us assume we are attaching the molecule there. After attaching a coenzyme A, the structure will be like this. So now if the fatty acid is activated, once the activation occurs, this will undergo beta oxidation. So therefore we know that beta oxidation happens between the alpha and the beta carbon atom. So in the first round of beta oxidation, 2 carbons are removed as acetyl-CoA. Then another round of beta oxidation, another 2 carbons are removed. Third round of beta oxidation, another 2 carbons are removed as acetyl-CoA. After this third round of beta oxidation, you are left with a fatty acid 1, 2, 3, 4, 5, 6. 6 carbon atom. This is adipoyl-CoA. Sometimes what is observed is this adipoyl-CoA converted to adipic acid, transported to mitochondria, and then it is entering into further oxidation, beta oxidation, and that can be cleaved completely. Or adipic acid has also other functions to be carried out in a cell, and this adipic acid will be used for production of such biomolecules. That is one possibility. And let us look at the next possibility. After removing this many acetyl-CoA molecule, so this will be C double bond OS-CoA. That is the fate of adipic acid. You are left with a 6 carbon atom. So if the next possibility is you can have one more round of beta oxidation, and if you remove one more round of beta oxidation, one more acetyl-CoA is removed, and this becomes a 4 carbon compound. This is nothing but succinyl-CoA. Succinyl-CoA also converted to succinate, and it will enter into mitochondria, and you know that once it enter into mitochondria, it will become succinyl-CoA and can continue with either TCA cycle, or it can get converted to other 2 acetyl-CoA molecules. So this is how the complete degradation of a short chain fatty acid or medium chain fatty acid is happening in the endoplasmic reticulum, very specifically endoplasmic reticulum, by activating at the omega carbon atom. So this kind of a fatty acid oxidation is known as omega oxidation.